A very warm welcome to today's video. Today we would be discussing a very important topic that usually comes in exams, that is real and apparent weight in an elevator. We all must have felt that sudden jerk while being in an elevator. So we usually travel in a elevator, and when we go up or we go down, we suddenly feel that jerk. We feel that our body has become lighter or heavier. So is it that case that do we really get heavier or lighter? Let us discuss that today. Okay. Uh, so for starting, uh, what is our weight? What we define our weight as? Our weight, what we define is the gravitational force that Earth is applying, that is m times g. M is our mass and the g is the acceleration due to gravity. But when we are in an elevator, we are either going up or we are moving down with an acceleration of, let's say, a. So then the normal force that the surface is applying to our body, that is n becomes our apparent weight, what we tend to feel, that is when we feel lighter or heavier. So let us discuss how it is happening. So suppose we are inside this elevator that is tied with a string and it is moving upwards. We are standing here and one force, that is mg, is being applied by our body on the floor, and normal force is applied by the floor on us. So this normal force becomes our apparent weight. Now, if we write Newton's second law of motion, we can see that we can take we can take g as this direction downwards as positive. We are considering this here. So we can write mg minus the normal force equals the acceleration of the body, that is minus ma. Since a is upwards, so we are writing this as ma, minus ma actually. So now we can write the normal force, that is our apparent weight. We can write the normal as m times g plus a, right? So we are feeling here heavier. Why? Because this acceleration is also adding up to our apparent weight. So this is the case when we are moving upwards. Heavier when we move upwards. Now, the second case, let's say when we are moving downwards. So here is our body. We are going downwards with an acceleration of a. The force being applied are your normal ng by our body and the normal force. Okay, so it is the case. Now Newton's second law of motion we are applying here. We are getting that mg is taken as positive, minus normal, all same, but the direction of a has changed here. But we can see the direction has changed here. It is now downwards. Earlier it was upwards. So now what we would do is we would just write it as m times a. Now when we find out the normal force, that is our apparent weight, we can see that it is m times g minus a. Now what is the case? We are feeling lighter here. So you can see how the conditions have changed as we are going upwards and we are moving downwards. While moving downwards. So we have seen how different these two cases are. When we are going upwards, we feel heavier, and when we are going downwards, we feel lighter. And very important, this is the third case. We can see that let's say we are in elevator and this is a string, and let's say the string snaps. Say the string snaps midway. So what we are going through, we are moving downwards with an acceleration of g. Isn't that the case? There is no acceleration. We're just moving downwards with g. The force we are applying is mg, and the normal force still becomes n. Now we can write as mg equals mg, that is the force, mg, that is the force, minus your normal force would be equal to your acceleration. What is your acceleration? M times your acceleration. Here we can see the acceleration here is g. So m times c. Now we can see that our normal force is 0. What we are feeling? You're feeling weightlessness. So we are feeling that we have 0 weight. So it is just the apparent feeling that we are experiencing. Right, whether it's weightlessness or let's say anything like we are feeling lighter, we are feeling heavier. So this is a very important concept while solving your questions, and the same concept applies to a weighing machine when put in an elevator. We usually see questions that weighing machine has been put up in an elevator, and we have to find and body is there, you're going upwards and downwards, what is the change in weight and all things. So we'll discuss that in the next question here. So let us start solving a question on this topic. What we're given is a man of mass 60 kg is standing in a lift accelerating downward at a rate of 2 meter per second. So let us draw a rough diagram here. This is the man who is accelerating downwards at the rate of 2 meter per second square. What is his apparent weight? So what we have done earlier is we list out all the forces acting. Mg is acting downwards and a normal force is being applied by the lift on the man, and this normal is the apparent weight, what we know. So the solution would be mg minus your normal force equals m times g, m times acceleration actually. So we have given m as 60 kg, acceleration as 2 meter per second squared. So let us put this into the equation. So from 1 we get as normal force is equal to m times g minus a. Will feel lighter when we are going downwards. So m is your 60 kg, g is our acceleration due to gravity, that is we assume it to be 10, and then acceleration is 2. So the apparent weight will be 480 Newton. This is our answer.